So I'm going to create a little function called at least 15, which simply says if the sum of the values in the list is at least 15, I'm done. And let's look at what happens if we were going to call this. I've got an example code here. Let me actually run it. I'm going to say, I'm going to call depth, be what I get if I use depth first search on a decision tree, good enough. I'm going to use my tree that I built here, so tree test. I'm summing up the values as before. I want all the weights below 10. And I'm going to say, I'm going to stop if I get at least 15 out. And there you go. Notice, again, it's come up with a solution, and it's found it after visiting only 4 nodes, and there's the solution it's got. If I do the same thing, but I'm going to now call it breadth, and I'm going to do a breadth first search of a decision tree, again, good enough, with the same tree, the same thing I'm trying to optimize, weights below 10, but at least 15. It finds the same solution. Thing worth 6, worth 7, and worth 8 can all be fitted in, but it took more time. It visited 8 nodes. And if you think about this, in fact, it is likely that in this case, breadth first search is almost always going to take more time, because it's looking down the decision tree. And remember, the decision tree would be at the top level, nothing, at the next level at most 1, at the next level at most 2, at next level at most 3. So I'm exploring all of these pieces, trying to find a solution in the breadth first size, whereas depth first is going to go as deep as possible in, which is more likely to find a solution earlier on. And so that's actually an interesting place where these two searches have different behavior.